Digital Practice Test 1, Module 1. A frequency table has a variety of numbers on the left and how many times they occur on the right. So this table here would represent the number 4 times, the number 8 3 times, and the number 13 twice. That's exactly what we have here, so A is our choice. Number 3 has to do with algebraic expressions. You match up walking with 3W, running with 5R, and the combined total is 14 miles. So it's important to note that W and R are time, a number of hours, and the output is going to be 14. So these are wrong because they have the wrong output. And then consider the nature of miles per hour, or 5 miles per hour, 3 miles per hour. The 3 and the 5 should be on top. A is the right answer. The interior sum of any triangle is always 180, so if we know two of those, 52 and 17, we can subtract. We get 111, which is what's left, so that must be the third angle. Number 5 gives you a graph representing the total charge for an electrician given X hours of work. Notice that there is a y-intercept, or a starting value. So that means that just for coming out to the job site, the electrician has a charge, and then the slope will tell you the hourly rate. So if you think about y equals mx plus b, this is the initial or starting value. It's also known as a one-time fee, kind of like just the charge for showing up. And the m is the per hour, or per some sort of independent variable. So here we're talking about hourly rate, which is A. Number 6, we have a distribution of different tiles. They have different colors and different shapes, and there are a total of 100 of them. They want to know, if we're choosing at random, what's the probability of selecting a red tile. So the total number of red tiles is 30, and the total number of tiles is 100. We could write the answer like that. We could say 3 over 10. We could say 0.3. They said write your answer as a decimal or a fraction. Any of those would be correct. Number 7, we're looking at a population of 50,000. We chose 1,000 for a random sample. And based on the survey, 35% of the people support this legislation with a margin of error of 3%. So that means anywhere between 32% and 38%. I just started with 35, subtracted 3, and added 3. And I'm going to apply those to the 50,000 because that's our population, not the 1,000, which is just our sample. So if I apply those two percentages, anything between 16,000 and 19,000 would fall in the expected range. The only one of those is C. I would solve number 8 like it was a proportion, x over 1. When you cross multiply, you get 55 times 1 is equal to x times x plus 6. If you distribute, you then have 55 is equal to x squared plus 6x. If we treat this like a quadratic, so we move and solve it equal to 0, we are now looking for, since a is 1, two numbers that are going to multiply to give us negative 55 and add up to give us 6. So if I think about some factors of 55, I think about 11 and 5, that jumps to mind, and those are 6 apart, so those are going to be some great choices. And one of them has to be negative, so I'm going to put it here, because that way, if I take x plus 11 and x minus 5, they multiply to give me negative 55, they add together to give me 6. And what do they want to know? They want to know the positive solution. So the temptation is to pick 11 because it looks positive. Remember, we have to plug in a negative 11 to make this true, when we have to plug in a positive 5 to make this true. So the positive solution is just 5. An airplane descends from an altitude of 9,500 feet to 5,000 feet at a constant rate of 400 feet per minute. What type of function best models the relationship between the descending airplane's altitude and time? So there's a lot of questions like this. Is it linear or is it exponential? And then is it increasing or decreasing? You have to look for keywords. Constant rate tells us it is not exponential. Descends tells us it is decreasing. So it's not increasing. The answer is B. Here is a function notation problem, and they want to know, and they, by the way, they tell you that y is the same thing as g of x, which is one of the more common mistakes or misunderstandings. They want to know the y-intercept. So what does that look like on a graph? Well, the y-intercept is when x is equal to 0, which, here's your clue, x is equal to 0 for all of these. What is y equal to? So you have to remember an exponent property, because if this is our function and we're taking it to the 0 power, anything to the power of 0 is 1. So this becomes 11 times 1, which is just 11. The circle shown has center O, circumference 144 pi, diameters PR and QS, and then it has some ratios for the lengths of arcs. The length of arc PS is twice the length of arc PQ. And it turns out that these are all equal to each other, across from each other, so I can mark it up like this. So if my entire circumference, the distance all the way around, is 144 pi, I can get that, and I can set it equal to all of these added together. So that's x plus 2x plus 2x. And then you might notice that the arc QR is 2x. So I'm going to divide both sides by 3, and this gives me 48 pi here on the left, which is the answer. Here's a rectangle with a length of x units, we'll call this the length, and the width of x minus 15 units, so we'll call that the width, and we'll call it x minus 15. If the area is equal to this, that means that x times x minus 15 is equal to 76. Or in other words, x squared minus 15x minus 76 is equal to 0. So let's factor this. What are two numbers that add up to negative 15, my b value, and they multiply to give me negative 76? I'm not super familiar with factors of 76, but a little trial and error, and it turns out 19 and 4. If you multiply those, you get this, and they're also 15 apart, so that's probably going to be our answer. And it looks like one of these will have to be negative, probably the bigger one, so that when we add them, we get negative 15. So x minus 19 times x plus 4. Let's look at my answer choices here. What is the value of x? Well, distances can't be negative, so negative 4 is not going to work, but a positive 19, there we go. Number 13, they tell us is exponential, so we're going to use the initial or principal amount. We're going to multiply that by either a growth factor or a decay factor. Here, it's going to be a growth factor, and we're going to take that to a power t. So how can I figure out the growth factor? I can just take two of these and divide one by the other. So in other words, I'm going to plug in 606.42 divided by 604. And if I round that, I get something like this. So let's first see which one of these have the principal amount in the right spot, and that looks a lot like C, but it could also be one of the other ones. Sometimes when you expand them, they look a little different. And which one has the correct growth rate? Well, that one's way off. So is that one. B and C both have the correct growth rate, but B does not have the principal amount in the right spot, or at all, anywhere. Number 14 is a systems of equations problem. They give you two different lines, and they want to know how many points, at how many points do they intersect. So you could solve this algebraically, set y equal to y, substitute in, and it turns out there's exactly one answer. Because if you recall, there's really only a couple of situations. You can have parallel lines that never cross, that would be 0 solutions. You can have two lines that coincide, they're at every single point is the exact same, so there's infinite solutions. Or the more common scenario is when you have two lines that cross exactly once. We're not going to get into 2 or 8 because these are not polynomials, these are just straight lines. So there's only one solution. Number 15, at a school fair, students can win colored tokens worth a different number of points depending on the color. So we see 5G, 45r, a total of 380 points. So this is an algebraic expression. The number of green tokens we multiply by 5. The number of red tokens we multiply by 45. It turns out those values, the coefficients in front of those variables, represent how many points each token is worth. So if I want to know the difference between the two, I take 45 minus 5. And this is a deceptively challenging problem, but it's actually just a subtraction problem. For the volume of a cylinder, which I think they give you as a formula, we're going to take the area of the base times the height. So the area of the base is a circle. So if the diameter is 8, that means the radius is equal to 4. So we're looking at 16 pi as the area of the base, and we're going to multiply that by 12. Remember that the area of a circle is equal to pi r squared. So we plug in the 4, and that's how we find the area of the base. 16 times 12 gives us 192. The answer is C. 18 is a systems of equations problem. I would probably use elimination. I'm noticing that if I triple this bottom equation, I can make my x-coordinates line up. So I will go ahead and do that. And I'm going to subtract all three straight down because that'll cancel out the x's. So I'm left with y is equal to negative 2, which turns out to be the answer because they only want a coordinate. They're expecting you to do it this way. Here is triangle JKL. Notice the angle J is a right angle. So the cosine of K, if you think about SOHCAHTOA, cosine is equal to adjacent over hypotenuse. The cosine of K is 24 for the adjacent and 51 for the hypotenuse. So if they want to know the cosine of L, that's going to be the same thing, but it's going to be x over 51. So I just have to figure out this third side. Since it's a right triangle, I know that x squared plus 24 squared is equal to 51 squared, according to the Pythagorean theorem. And this is how I solve for x. I move things over and I take the square root. And this part you could certainly do on a calculator, and if you do it, you get 45. So I'm going to plug that back into my triangle here. And cosine of L is adjacent over hypotenuse. So here, 45 is the adjacent, and the hypotenuse is 51. Any of these say 45 over 51? Oh, this is the fill-in. So 45 over 51. Number 20, I have a parabola, or a quadratic, and they want to know for what value does f of x reach its minimum. So notice there's a positive value in front of x squared, so that means I'm going to be looking at a u-shaped function, and we're going to be looking for the vertex to be the minimum. If you recall, the formula for the x-coordinate of the vertex is negative b divided by 2a. So here that's negative, I'm going to plug in negative 50, divided by 2 times 4. So 50 divided by 8. So my x-coordinate is 6.25. And that is actually the value that f of x, or y, reaches its minimum. So 6.25 is the answer. Line L passes through 0, 0, and it's parallel to this line. Parallel means they have the same slope, so the slope is equal to 8. And because it passes through 0, 0, my b value, or my y-intercept, is equal to 0. So I can write that as y is equal to 8x. That's my line. It also passes through this point, 3 comma d. So I can plug that in, d for y, and 3 for x, and d is equal to 24. We're looking at when a line crosses a parabola at exactly one point. And this is my parabola. What is the value of c? So I'm going to keep in mind that to find the x-coordinate of the vertex, I can use this formula, negative b over 2a. So here that's negative 9 divided by 2 times negative 2. Or, in other words, it's going to be 9/4, or 2.25. If I wanted to plug this in to the equation, I would get 10.125 as the y value. And here's a rough sketch of what that parabola might look like. So remember that the line has the equation 2y is equal to c. In other words, y is equal to c over 2. My y-coordinate is exactly 10.125. So I can take 10.125 is equal to c over 2, or in other words, 20.25 is equal to c. And that's what I plug in for the answer. If we plug in this value for c and divide it by 2, we'll get y equals 10.125, which is this line here. And their point of intersection is at the maximum, or the vertex, of the parabola.